Alright, I just want to say thanks for coming out to my speech. It's to do with engines, so it may be a little boring.
I noticed there's a gas station right down here at the end of the road that I see a lot of people at all the time getting fuel. And the one thing that always occurs to me is that it's amazing that people don't understand what it takes for a gasoline engine to operate.
I noticed there's a gas station right down here at the end of the road that I see a lot of people at all the time getting fuel. And the one thing that always occurs to me is that it's amazing that people don't understand what it takes for a gasoline engine to operate. They just put the fuel in and just kind of dry off. Obviously there's a million little processes that are involved in making a gasoline engine work, but we were just going to talk about a few of the basic principles and maybe even touch on some of the basic parts. First thing we're going to talk about is the combustion of gasoline itself. Gasoline is a fairly readily available fuel that people can use.
The gasoline itself produces an endothermic reaction, or exothermic reaction I should say, and that just means that whenever you light it, it actually produces more energy than what it took to get the gasoline started on fire. The output of gasoline is something like 125,000 BTUs per gallon, and that's about comparable to what most household heating units produce in an hour for your home.
Now gasoline, just like any other fire, requires that you have three ingredients. The first ingredient, of course, is the fuel itself, so gasoline is its own fuel. It has to be in the presence of oxygen, and it also has to have some sort of heat or spark to get it ignited. And the thing about gasoline working in an engine is that it's actually useless unless it's contained and controlled. Obviously, if you light gasoline on the floor, all you'll get is a poof and kind of a flame. You need to have it controlled in some sort of way, so what people have done is put it into a cylinder. Now, if you think about putting gas inside of a cup, and you light that, the flame will come up out of that cup. If you were to put a lid on top of that cup and then light that, the lid would blow off. And that's kind of the principle that motors work on, is they contain the fuel and cause it to be ran through a system that mechanically translates that heat and expansion into a mechanical motion. Now, how does it actually cause an engine to turn over is a mechanical operation, and I have here a part of an engine that's referred to as a piston. Now, if you think of this part right here as what is the lid on this proverbial cup that we're talking about, you place the fuel in there. When the gasoline goes off, it forces the piston to move. Now, what happens is the fuel is injected into the cylinder and ignited, and it pushes this piston down, and it does it with this connecting rod here. It goes around a crankshaft.
Each movement of the piston up and down by itself is considered a stroke, or what's called a stroke. And most cars these days operate on what's called a four-stroke system. So you'd have up, down, that's one complete cycle.
Now, what we have here is a little bit, so I can find the starting one, of a representation of what I was talking about. This right here is your piston. Here's a connecting rod, just like I was showing you earlier. And this is the starting position of this. Right down here is where your crankshaft is. This valve right here opens up and allows fresh air and fuel to come in. When it comes in, it's coming in because this piston is coming down and creating a vacuum inside of this area. So as this piston turns around this crankshaft, it's coming down and drawing fresh fuel and air into the system. Here we go. So as it continues around, it goes past the very bottom, which is referred to as bottom dead center, and starts to come back up. As it's coming back up, this valve over here closes, and it starts to compress all this air and fuel that it just sucked in on this intake stroke. Now, it compresses it for two reasons. One, you get more fuel and more air into a smaller area, And two, at the same time, because of compression, it raises the temperature, so it gets it that much easier for it to start the firing process. After the piston travels all the way to this hop, of course right here you can see that both valves are still closed. What happens is your spark plug actually creates a spark and ignites this fuel. And then that will of course cause it to come down in what's referred to as the power stroke. So as it comes down, the power is transmitted through the gasoline, and it's exothermic reaction, and helps your crankshaft to turn around.
So it's these 4 strokes going continuously inside of your engine. You know, you start out with your intake stroke where it draws in fresh air, and then it comes back up compressing after it's closed both valves. The power takes off, pushes it back down, and then your exhaust valve opens, it comes back up, and it blows exhaust out. So that's your 4 strokes.
So as you can see, the explosion created with gasoline, when it's properly controlled, there's the actual opportunity for movement to be created. Now the process of getting fuel from the gas tank to the engine and mixing it properly is controlled by one of 2 things. From the beginning of motors pretty much until 1985 or so, people used carburetors. And your carburetor is just merely a system that brings fuel from the tank by a fuel pump, puts it into the carburetor, and as air comes through the carburetor, it sucks just enough fuel into that mix to go into the system. There's a low pressure setting on that. The fuel that comes in is only about 7 or 8 psi, and in order to accelerate the air, there's butterflies inside the carburetor that actually open up and allow more air to come through and thus drawing in more fuel at the same time. Now the newer motors, since 1985 to present, have fuel injection. Fuel injection runs with a single injector, similar to what the spark plug looked like, injecting fuel into the cylinder directly, and whenever, instead of trying to meter through vacuum like the carburetor will, it actually just directly measures how much air is coming in through sensors and other things. Now there has been fuel injection since the mid-50s, but that was a mechanical system. There wasn't any real way to measure and make sure that you were adding or subtracting the right amount of fuel. With the advent of electronic ignition, fuel actually can be metered and controlled better. Also, diesel engines typically work off of fuel injection, so they don't actually have carburetors. So as you can see, there's many ways that things work together to make a car operate efficiently. Ever since Nicholas Otto, the inventor of the 4-stroke system, invented this in the late 1880s, it has worked pretty well, and I think that the gas station down the street is probably going to maintain its business.